thought you said the mic was quiet. Okay. Hello, everyone. Welcome. Welcome to Can You Keep a Secret? Today I'm going to address an important security topic, which is secrets, and how we as Drupal professionals can do a better job of protecting our sensitive information. I've got to say, I was expecting for a security topic a very intimate crowd, but this is awesome, so thank you. My name is Nick. Oh, how did that get up there, that photo? My name is Nick Santamaria. I've worked with Drupal since version 4.7. In June, I started with the previous Next crew, and I work mostly on our hosting platform and infrastructure projects for our clients. So, this session is going to have three overarching themes: what secrets are, the different forms that they take, why we need a tool or tools to manage our secrets, and the consequences of doing otherwise, and how we can implement secret management into Drupal projects. So I've tried to give this talk fairly broad appeal, so hopefully whether you're a junior mid-level site builder through to senior architect, mad developer, business person, contrib maintainer, I hope that you're all able to take something away from this. So what are secrets? Loosely speaking, a secret is any piece of information that you want tight access controls around. A piece of information which, if exposed, could bring harm to your organization. And this harm comes in the form of financial loss, regulatory fines, loss of trade secrets, or even more vague harm. So things like, maybe harm, like damage to your brand or reputation. And maybe your customers no longer trust you. Next time they want to make a purchase, they'll go to your competitor. Secrets are used by both humans and software. But today's focus is going to be on secrets found in web applications like Drupal, so things used by machines. Alright, so I'm going to just quickly run through a few different types of secrets, and this is a little bit of audience participation going on. For each of these examples that apply to you or your organization, I want you to visualize the worst case scenario if someone with the means and motivation to hurt you got access to it. So first up, username and password. So in Drupal apps, typically used for connections to your backend services. MySQL, Redis, Apache Solr, MongoDB, things like that. Next up are API keys. These are used for Drupal to authenticate to external services. Things like your cloud providers like AWS, payment processors, PayPal, SecurePay, Stripe, your email marketing platform, parts of your CI/CD platform, GitHub, Jenkins, all of these services have this concept of API tokens. Crypto keys. So these are used by machines to encrypt data, both over the wire using TLS or in your long-term storage. And these are things like your SSH key pairs, your private keys for your SSL certificates, and AES keys for encrypting parts of your database or your data at rest. Okay, so you guys all still thinking about worst case scenarios, right? So there's also a few other classes of data which meet some definitions of a secret, i.e. they'll cause you harm if they're exposed, but they're not technically considered a secret. This is just data that you want to treat with care and encrypt it using a cryptographic key, which we do consider a secret. Alright, so, wait, hang on back here. Cool, so I'm going to try something, bit of audience participation. Guys in the front row, you're on the hook.
Hello. Alright, so who here is, whose Drupal site connects to AWS in some way using the API? Anyone? Yeah, Mike, you're on the hook. Alright, so if someone got access to those keys and they wanted to hurt you, what could they do?
They could probably help me print my resume, I think.
Yeah.
Would be lovely.
Yeah.
But they would gain access to all of our public and private files.
Delete them.
Delete them, copy them, change them.
Run up your bill to like whatever.
Yes.
Cool. Okay, who here has an e-commerce site connects to PayPal, SecurePay, something like that? I know you do. You're all lying. Here we go. Sai. What would happen if someone got access to that?
I don't know, but I know I have to treat it carefully.
Yeah, well, I mean, they're going to try and charge or do chargebacks on your account and things like that. Yeah, it's all pretty dangerous. Cool. All right. Well, that'll do.
You should have coached me.
All right. Well, that's why we're here. Cool. So hopefully that gives you an idea of the scope of what we're talking about here. But the meat in the sandwich is how we get these secrets into the Drupal app so it can do its things. I'm just going to run through a couple of common approaches you'll be familiar with. So first up is storing your secrets in your repo in plain text. So this is a pretty common way to configure your production database. As you can see there, we've got username, password for prod in the plain. Drupal's config export API also does the same thing. So most modules will allow you to enter the API key for the service you're connecting to. And when you export these into your repo, it ends up like this. Now, the issue with this approach is that anyone with access to your repository has full access to all of the services which have the API tokens stored in your code for. So this is contractors, former employees, people who are supporting your hosting platform. All those guys have full access to your Mailchimp account with this. There's also storing it in the database. So Drupal 7 had the variable table. Drupal 8 has the config table. Just to demonstrate here, I've done a simple query looking for things in that table that look like a private key. And all of the highlighted ones are secrets. So, we've got Mailchimp, we've got connection to Acquia, Discus. Whoever gets access to your database now owns all of those services. And yeah, and it's not like, you think about, okay, so my devs have access to the database, but developers here, I know you guys, you're making SQL dumps like multiple times a day. You're syncing them between machines, you're putting them in different spots on the file system, you're sending them through Slack. Think about the types of people who could just stumble across these files and get them, and now they own all of these services. You can also use an infrastructure config management tool to do the job. This approach usually involves using Ansible or Puppet or Chef to dynamically create a file on the web server that contains a secret. Drupal will then run some code to read in that secret and put it into the right spot in the configuration array. So this has a few advantages. If we compare to the last two approaches, when your repo or your database are leaked, you're fully owned. In this approach, the secrets are only ever present on the web server. But it doesn't come without its challenges. If your hosting uses an auto-scaling architecture, typically you'd use pre-burnt AMIs. And so if you're burning your secrets into your AMIs, that means you need a new AMI per security boundary. So for each of your clients and for dev and prod, you're going to need a different AMI. So that scales up really quickly and can be a real pain to manage. You're also going to have to work out how to encrypt your secrets in your infra code. There are tools to do this like eYAML and Ansible Vault for Puppet and Ansible, but there are non-trivial issues around how you orchestrate the distribution and rotation of these keys. And finally, you probably laugh, but I see this all the time, guilty of it as well, is putting SSH public keys into production servers and things so your devs can access it. And the worst part about this is that when you put it there by hand, there's no known source of truth. Where did they come from? Password manager, a spreadsheet, a text file on Dave's laptop, who knows? So what's the problem? Well, if your organization uses these approaches to manage your secrets, I guarantee you're either A, spending a huge amount of time and resources on maintaining the systems and rotating keys and provisioning and revoking access through staff turnover, or your organization is right now exposed to a huge amount of risk and you're only one mistake or one bit of bad luck away from being compromised. And here are a few reasons. One, secret sprawl. So this is the term that we use to describe the tendency for organizations to store their secrets in a, let's say, ad hoc way. So in an organization of any size, you've got different departments, and each of these departments has different applications and different teams within those departments, and within your teams you've got different people with different methods and approaches and care for the kind of security around it. And this, like, there's a term I want to use, but I won't, but this makes it really difficult to answer really simple questions like, hey, where are the credentials for this service? Or, hey, who has access to these private keys? And which systems are using this API token? A consequence of secret sprawl is that there's no reliable way to monitor and audit usage of these secrets. You have no way of knowing who used the secret, and you have no way of knowing when they got access to it. So if your app gets compromised, it's pretty likely that you will never find out. Another knock-on effect of secret sprawl is it makes rotating your keys like really difficult. But Nick, why bother rotating your keys, you ask? Well, as the lifetime of a secret increases, so does the chance of exposure. And that chance of exposure never stops. It will eventually, guaranteed, be exposed. And this happens through a couple of mechanisms. Some innocent, like caches or logs, backups, but also in more malicious ways. So someone intentionally trying to crack a private key, or brute forcing your password, or getting access to some kind of database dump or leak with your details. So these legacy approaches we discussed before, they present the challenges for rotating keys. So let's take the example of changing an API token. Hopefully there's good documentation to say, hey, so this token is used on these applications, and this application lives on these servers, and it has permission to do X. Assuming that's all good, you provision a new key, add it to your Drupal configuration, go through your whole deployment process. All right, it's all working, great. You revoke the old key, and sometimes stuff stops working intermittently. Maybe you missed a server. Maybe someone just decided it was easier to share a key and not tell anyone for a different application. So these types of problems just plague the process of rotating keys, and that's why really no one does it. And think about rotating your SSH keys. Everyone here, I guarantee, has done this. You get a new laptop, create a new SSH key, you put it on the 1 or 2 servers for the project you're working on, but for the next 12 months, every week, you hit a new server that it's not on. And you have to send an email off to Dave in Ops with, saying, can you put my key on server X? And it's whack-a-mole. You go through this process for the next 12 months. And what about when staff leave the company? SSH keys, they get left on production servers. IAM users, they get left in AWS accounts until someone notices that Bruce from 3 years ago still has full admin access to your account. And so finally, I want to talk about what happens when you've been compromised. I'll paint a scenario for you. So you're at your desk and your boss rushes over to you in a panic, tells you that, we think that there's been a leak of the customer database. The phones are ringing off the hook, people are complaining. Your CEO, he's like breathing fire, demanding minute-to-minute updates of what's going on. And all eyes are on your team to deal with the problem decisively. But keep cool, you know what to do. You and your team, you documented meticulously what needs to happen in this exact scenario. So you run a few bash commands, click around, revoke a few keys, and you've contained the breach. Cheers erupt from the office floor. You go home on time, and you have a beer when you get home to celebrate. Good job. But that never happens. That is pure fantasy. The way that this scenario plays out in real life, I'd say when the boss rushes up to you with that kind of information, you would react more like this. Followed by a frantic 10-hour scramble to manually plug all of the potential sources of the breach. So, hopefully I've done enough fear-mongering to convince you this is a problem worth solving. And the solution comes in the form of secret management. So these are tools and managed services which centralize your application's secrets inside the digital equivalent of a bank vault. I just want to quickly compare the challenges of the old approaches with the new way. So, secret sprawl. Well, now that we have centralized the storage of our secrets, there's an unquestionable source of truth. Your developers access secrets through a single standardized REST interface, and you have a much smaller surface area to protect. Answering the unanswerable question of who has access. Well, now every single human server or application needs to identify itself and authenticate before it can get access to secrets. And this authentication can be in the form of a username and password for humans, or an instance profile, or some kind of API token for machines. Every identity that belongs to a role, and each tool out there has its own framework for managing policies around what these roles can do and what secrets they can access. Answering who asked what and when did they do it. So now that all your systems have to come in through the front door, it becomes trivial to create an audit log and monitor for abnormal activity. And in the event of a security incident, some kind of breach, you can review your historical logs to track down where the breach originated and understand the scope and the impact for your postmortem. The rotating secrets issue. So now all your secrets are in one place. You rotate them in your secret management system, and the changes propagate immediately. Secrets can also be leased, meaning that they get a specific lifetime, and after that period, they're no longer valid. And there's also this cool concept in some tools called dynamic secrets. And this is very cool. I want to talk about this a bit. So let's just say that Drupal asks HashiCorp Vault for access to for an AWS API key, and it wants this so it can talk to S3 to read and write a few objects. So in the background, on the fly, Vault creates a brand new IAM user in AWS. It passes the API keys for that user back to Drupal and says, hey, in 36 hours, these keys are dead. So Drupal's like, great, cool, that's awesome, and it uses them happily for 24 hours. At 24 hours, it'll repeat that same process, ask for new keys, and Vault will do the same thing, new user, new keys, 36 hours, back. So that's great, and it'll do that continuously for the lifetime of the app. And after that 36-hour window is up for any given set of keys, Vault actually goes and deletes that user from your AWS account. So what this means is that if your code base or database, wherever Drupal is storing these secrets that it's getting from Vault, if they are compromised, if they're leaked, those keys are only potent for 36 hours at most. After that time, they become just junk data. The attacker can't use them to do anything. And Vault supports this concept for a number of different services, including MySQL, SSH credentials, RabbitMQ, and there's quite a few more. Another problem, how do we solve that face? Well, now, in the event of a breach or a suspected breach, you have a well-defined boundary that you need to contain. You can rotate all of your secrets very quickly in one spot because you know where they all are, and you can do root cause analysis using your audit logs. Alright, cool. So, I'm going to do something a little irresponsible. How are we going for time? I can't see. Yell. 10 minutes to go. All right, cool. We're going to try and rush through this. So I'm going to try not 1 or 2, but 3 demos. So I made a serious offering to the demo gods this morning. I'm not sure that they're on my side yet. Can I get a little noise? Like, let's get it going. Woo! Yeah. And every time something works, same thing. All right, cool. So first demo, we're going to look at securing the storage of API tokens in a secret management tool called Locker. So Locker is a commercial service. It's very simple, but they have a very good pricing structure. Integration with Drupal is good, and they told me that an Asia-Pacific region is coming soon. All right, so let's look at the setup. So first, we're going to need an account with locker.io and a Mailchimp account for this example. On the Drupal side, we're using Drupal 8.4. the Mailchimp module, the locker and key modules. And for the key module, we're actually using the dev release at this point. There's a brand new feature that I'm showing off. It's going to be in the upcoming 1.4 release. So let's get into it. Okay. All right. Sweet. So, got a Drupal site here, already logged in, and with the modules already set, also already in the code base. So, step one. So we're going to go to the module page and enable a couple of things. So first, we're going to enable locker. And so this has a dependency of the key module, which is going to get enabled by default, and also the Mailchimp module. Can everyone see that? Is that? Yeah, cool. A bit larger. Alright, cool. See how this goes. And yes, I do understand the irony of using admin for a security talk. Thanks guys, you're the best. Alright, cool. So, while that's installing, what we're going to do first is, alright, we're going to go to locker, the locker config, and set up our connection. So, this uses TLS client authentication to do its thing, so we'll go into Auckland, and DrupalSouth. So this creates a little certificate on the fly. That seemed to work. We'll ignore the error. Cool, so I've logged in with my account that I signed up for on Locker. Alright, great, that's there. Next we're going to go to the Mailchimp config page. Mailchimp, is it there? Yes. Alright, cool. So it's asking for the API key, so I've pre-logged into the Mailchimp dashboard. Grab that. So this is the old way. So now if I did a config export, this would be in my code base and repo and all of that stuff, which is no bueno. So instead, we're going to go to the key module and add a new key. I'm going to call this Mailchimp token. Use the locker key provider. So the locker key provider is going to make sure that our key gets stored securely in that remote key store, and I'm going to put my API key in there instead. Excellent. Now, this brand new feature of key module I was speaking about is the ability to override any configuration entity value with a key. So for that, we go to our config settings and key overrides. Add an override. Call this Mailchimp API. It's simple configuration. Mailchimp and API key, and we choose the token that we just created. Save that. Boom. All right. It's that easy. All right, back to the slides. Where are they?
That won't be exported now if you do the config sync.
Here we go. So this is what your config sync used to look like, and what it would have looked like if I just stopped at that first step. But now, it resets that value to null. So not in that file anymore, but what about this file? No. Okay, so this is the where it exports the key configuration entity, and you can see there that this is just saying it's stored in locker, and here's a encoded hash of where it belongs. So it's not in that file either. And then we go and have a look at our config override config, and this is just mapping the Mailchimp API config entity with our key. And so this all is just magic, and it happens, and every time now you go to use the Mailchimp API, it will use those credentials. So the advantage of this approach, your attackers, they can't obtain API keys from either DB leaks, your code base leaks, or maybe, you know, developer machine gets stolen and they had some stuff on there. So, cool. Can we do after? Because I'm really running short on time. And that's dope for those who knows Kelsey Hightower. Cool. All right, next demo. We're going to try and encrypt some field data using Amazon KMS. So the setup for this, we're going to need an AWS account set up. We're going to need an IAM user with access to decrypt and encrypt using a KMS key that we also have created. On the Drupal side, Drupal 8.4, again, key module, but this time we're using Encrypt, Field Encrypt, and a brand new sandbox module from me, which allows you to use a remote encryption key in KMS. All right. Let's get rid of you. How are we doing for time?
2 minutes.
Oh my god, no, this is not going to... Alright, we're probably only going to get through one demo, 2 demos, sorry. Alright, so on here we have a Drupal site where we're storing people's passport numbers. Probably not a good thing to lose. So we're going to encrypt these in our database. So if I jump into our database here, don't know if you can see that, but these values are stored in plain text. So again, first, jump to the... kidding me? Cool, so we jump into the module enable page, and we're going to add the KMS Encrypt module, and that'll automatically install the Encrypt and key modules, and we also need the Field Encrypt module. Cool, so install those two bad boys, and while that's enabling, this is my lovely sandbox page description, so check that out. And for those who have never seen a KMS key setup, so this is the IAM dashboard in AWS, and on the left here you've got this encryption keys dashboard part, and I've created this DrupalSouth demo 3, although it is demo 2, don't know what I was thinking. Okay, so let's rush through this. There's a couple of config things to set up, some I've pre-done. There is a Encrypt KMS settings page where you'll add your AWS key and private key. But first thing that we want to do is add a new key. I'm going to call this key KMS ARN. And so this is not technically a secret. This is just telling the key module that we have a KMS key, and this is just the identifier for it. How are we doing for time? Within like 10 seconds? Okay, cool. So that's there. Next, we're going to create a configuration, an encryption profile. Let's call this KMS demo. And we're going to select the Amazon KMS encryption method and the KMS ARN key, which we just created. That's there. Boom. All right, now we're going to go to our user entity field settings. Cool, we've got our field passport number, go here, change the field settings, and we're going to encrypt this bad boy using our KMS demo encryption profile. Sweet, alright, now, hopefully we can just get the money shot on this one. So with our users, we're going to go into Hans's account, and we're going to resave his passport number. Here we go, fingers crossed. Big applause if this works. Okay, cool. So that didn't die, which is a very good start. Now we jump into our database and refresh this, and that GER should now be an encrypted blob. Can I get going? Or are we too tight?
5 more minutes.
All right, 5 more minutes, sweet. Yeah, cool, all right. Let's keep it going, keep it rolling. All right, so advantages of that. Now your you came out too early. Your sensitive data is not exposed in a DB leak. That's like your customer data. Your decryption keys are not stored in the code base, so if someone gets the DB and the code, they can't decrypt your stuff. And you can simply secure this by rotating the AWS API token that your site is using to authenticate. Thanks, Kelsey. That's pretty dope. I know, I agree. All right, last and not least, this is dynamic database credentials with Vault. So this isn't technically a Drupal integration thing, but this is just a very basic introduction to what these dynamic credential stuff does. Setup for this is, got a Drupal site, but it could be anything, WordPress, Java app, NPM, whatever, because we're just writing out a template file. We need a HashiCorp Vault instance. I'm not going to go into that because that is could do a whole day session on that. And we're using a little templating tool called Console Template to read the values out of Vault, store them into a template file. So just very quick primer on Vault. First, we tell it that we want a database secret backend. Then we give it root access to the database. So you can see here just saying, hey, this is the connection URL for the Drupal role. We then say, hey, when you create the Drupal role, we're going to run this SQL statement. And those mustache braces are showing, like the username, password, and the database name. And we also say, give it these TTL values. Now, for this demonstration, so I've set them very low, like 15 seconds. But in your typical use case, it's going to be like an hour or a day or whatever is applicable for your security use case. And we just run a quick test to make sure that this is all working. And you can see that you should be getting a password and username at the bottom there, which look like just random junk, which they are. This is the template file. So this is just writing out a Drupal settings PHP. I've omitted the stuff you don't need to see. But basically, we've got this with secret declaration, which is saying, make a GET request to Vault to this secret endpoint. And then we use the username, password, mustache tags to put them into the right spot. Final part, we run a service using, we run console template as a service, putting the template and the rendered output together. All right, we'll demo this bad boy. So, where are we? Cool, so I've made a very secure block which gives you your database credentials. But this is what believe me, this is what is in the databases array for this particular Drupal site. Now if I switch back to this workspace, I've got a watch on this. So if we make this nice and big, this is just every 2 seconds cutting out the contents of our configuration file that's being rendered. So you can see that just changed. Boom. Oh, that's real credentials. And at the bottom, I've got another script which is just asking MySQL for the list of users in the data that have access to this table. And so you should see things get added, cool, change there, and these will get ripped out in a second automatically as well. Woo! So, advantages of this, you're constantly rotating your secrets, which eliminates that key rotation problem. By the time an attacker has time to use your credentials, they're probably junk. And the risk posed by secret hoarders is mitigated because their stuff is junk after after a certain given amount of time. And that is extra dope. Thank you.